Okay, today we're going to review our quadratic functions vocabulary, So our parent function is going to be y equals x squared. We're just looking at the very basic. Just like our linear parent function was y equals x, our absolute value parent function was y equals the absolute value of x. Our quadratic parent function is y equals x squared. Nothing added, nothing multiplied, just the basic. Now, the graph of a quadratic is what we call a parabola. The equation is a quadratic. The graph is a parabola. The shape of the graph is a parabola. Now, the axis of symmetry is the line that cuts the parabola exactly in half. So here, this arrow is pointing to the axis of symmetry. For the parent function, the axis of symmetry is the y-axis. It's not always going to be the case, though, once we do a transformation off of the y-axis. So the axis of symmetry is always going to be a line. And when we give the axis of symmetry, since it is a line, it's going to have to be a y equals the number, because that is how we define a vertical line. Y equals 0, every y on the line equals 0. That's what makes it a vertical line. Okay, now that axis of symmetry makes a mirror image. So this point right here has a mirror image on the other side of the axis of symmetry. So if you know the axis of symmetry and a point on one side of the parabola, you can go find the mirror point on the other side of the axis of symmetry. All right, we then have vertex. Vertex is going to be the same thing as the minimum or maximum of the parabola. So the vertex here for the parent function is right here. This is at the point 0, 0. Now, in this particular situation, the parabola is opening up, and so my vertex is also a minimum point. If the parabola is opening downward, then the vertex is going to be a maximum point because it's going to be the highest point. Now, the way that the graph opens, this is concave up. I'm going to run out of room there. This is concave up because the arrows are going up. It's like a cup, all right? If you could pour water into it and it would hold it, it is concave up. Now, we refer to the direction that a parabola is opening as concavity. So it's either going to be up, or concave down. Okay, so I know I'm going through that fast. Sketch yourself a picture in your notes, and then hit pause, sketch the picture in your notes, then hit play again, and we'll finish up real quick. Okay, so here we have a transformation of the parent function. Now let's start with our axis of symmetry. Okay, our axis of symmetry is the line that cuts the parabola exactly in half. Okay, so that is always going to be a line. Told you we are going to always define vertical lines as y equals, and it looks like y is going through positive 1 right there. Okay. All right, now you all know, let's see, here's our low point down here. Let's do green. We're going to do our vertex down here at the bottom. Now this particular vertex is a minimum because the concavity is concave up. And I know that because my arrows of the parabola are going up, so I could pour some water in that parabola and it wouldn't spill. Okay. Now, let's look at some basics that we get for every graph that we look at, we have a y-intercept. Now notice here, the y-intercept is down here. This particular one is at 0, -3. Now we also have x-intercepts. Now notice in parentheses under here, we have the word solutions. Now here's what you've got to know about quadratic equations. Quadratic equations have 4 names for the same thing. You all know them as x-intercepts. They are also going to be called solutions. They are also going to be called zeros, and they are also going to be called roots. All 4 of these things mean the exact same thing. So here I have, and let me erase there. I've got 2 x-intercepts, 2 solutions, 2 zeros, and they are at the points -1, 0, and 3, 0. Okay. So we are going to go to one more page, and I'm just going to have the definitions listed. So in case you have not gotten them written in your notes, you can do that. That will be all. So here are the definitions, a little bit more official if you want to double check and make sure what you have in your notes. Vertex, concavity, axis of symmetry, and x-intercepts.